introduction into this key registry. We have a set of key registry, about 12 in the Netherlands, a number of geo-registries, geo-referenced registries, like building and addresses, or the cadastre, but this is also one. But also non-geo-referenced, like the personnel or addresses, or one with the license plates. But this is a specific one, this is the last one we still have to develop. Then I take you through the business case for this say public initiative, where we actually implement a law. And we always do a societal cost-benefit analysis. And I use this to illustrate you what the importance is of the subsurface in the building and construction world. Then demand for GeoBIM. And I want to take you to the next generation, because I think there's still educative measures that the young generation, we have to teach them about the subsurface. I'm a geologist, and I love the earth, because that's why I study geology. But I hope more people will do that. Also in the civil engineering world. What is in this key registry? It's a very large key registry. To give you an impression, it's the domains of civil engineering, agricultural management, water management, the groundwater management you should incorporate, natural resources, oil and gas, and mining resources, but also geothermal, nuclear waste disposal, soil pollution, soil remediation, and pollution sites, and archaeology. We implemented in the coming 7 years. We faced the 2 stages. Other key registries, like the key registry for the large-scale base topography, have about 60 objects. Here we talk about 250 to 300 objects, just to give you the task we have ahead to implement this. They all have to be harmonized, a legally agreed data model, and we implement them by legal implementation. And a key registry means that it's obliged usage by all parties in the governmental agencies, and obliged back reporting means if you see any mistakes, you have to report them back, and apply data delivery, and it will be open data. Now, the domain of the subsurface is under 2 political responsibilities of 2 ministries. From 0 to 500 is the Ministry of Infrastructure and Environment, and from 500 to 5,000 meters, or the core of the earth, is from the Ministry of Economic Affairs. That's where the oil and gas and natural resources resides. In the Netherlands we have an act, it's called the Localization Act, or all-in-one permit. This act means actually that we try to combine all the laws and permits of the subsurface and SURFs in one all-in-one permit. Only in the subsurface, I just show you all the laws, there are already 12 laws which you have to adhere to when you have to ask for permits. So that is also quite an important task for the Omgevingswet. Now, this law has been approved this year in the Chamber. It took 7 years to get it to the Parliament, it's quite normal. I was lucky to succeed it, the first and second chamber, so we have a law. So people now have to adhere to the law, which is quite convenient, but not easy, because the users have a need for the subsurface. It's usage in front, not the law. By law only making it obligatory, you don't make it. And what we have in the law is basically 4 objects: the measurements of the subsurface, licenses, mining licenses, production licenses, geothermal licenses, any construction in the subsurface, and models. And I'm going to show you a bit more about the models. And what's in this? The objects has cone penetration, if you have to build on steel, or you can actually not use piling. That's quite important. How the composition is, sand, clay. It has also impact on, for example, life expectancy of piping. Other data is the soil data from the agriculture area, quite important for agriculture measurements, and groundwater levels. Groundwater measurements. In the Netherlands, we're fingering the dike, we always have wet feet, but 70% of our drink water is from the groundwater. And we've also, a lot of dikes have problems because the groundwater emerges underneath the dikes and cause collapse of the dikes. So it's very important for us to measure it. And we have more than 120,000 groundwater measurement wells, which we monitor daily with all kind of sensor data. Oil and gas, we have 350 oil and gas fields in the Netherlands. We're one of the largest gas fields in the world, the Groningen gas field. And we also have licenses, geothermal licenses, so all the licensing are in it, in this key registry. And then the models. This is quite oddball compared to other key registries. We have 2D models, morphological maps. As you can see, it is from Altera, University of Wageningen, make these maps. They are world famous for their soil modeling. We do it in a lot of countries around the world. And then the geological survey, they have 3 levels of models. Basically the deep, for the deep subsurface, up to 3,000 to 4,000 meters. We have the geological model for the geohydrological elements, so where your groundwater bodies are. And then we have the geotop, specifically made for the Ministry of Waterworks and infrastructure developments, which is the upper 30 to 50 meters, where also all the geotechnical elements are happening. So what is the business case? And that's basically asset management in the public sector. Our colleagues in the UK, who are going to implement the BIM as a legal mandatory obligation, they also, and also in the US, found out that 37% of project overruns that are cited by the Civil Engineering Society in the UK, but also in the US, are caused to problems for underestimating the subsurface. 70% of public projects of these 30 were delivered late or over the tender price. Now, we had similar projects in the Netherlands. I'm not going to mention them, but they had big project overruns. In Vredenburg and Utrecht, or the A4. Now, if you look in the Netherlands, we did together with the Ministry Rijkswaterstaat and also the universities an analysis of all the infrastructure in the Netherlands, and we think, or we estimated from this 5-year research program, Geopulse, that 2 to 5% of reduction of construction failure costs can be reduced due to the subsurface. This is based on hundreds of projects in the subsurface in the Netherlands. Annually, in the Netherlands, we spend about 1.8 billion euros for infrastructure works on roads, railways, and 450 billion euros for our dikes. Now, if you could only save 1% by better using the data of the subsurface, you already have a unique business case. And I did this in a normal way, do a capital expenditure in the oil and gas field. We have to spend the coming 4 or 5 years, and I present this to the minister as well, and they're discussing about it now, about 22 million to get this database in place, get the law implemented. But the return on investment over the coming years, when you only take this infrastructure fund and the Delta fund, and I do not take the private partner, the utility companies into account, is more than 128 million net present value. So it's quite a profitable thing. Even we could do it by crowdfunding, and being popular this day. It's a good investment. It is an investment for the public sector. If you look at the stakeholders for the subsurface, a lot of our, there's Energy Management of the Netherlands, a very large energy company, a natural gas company. The Ministry of Waterworks, the Rijkswaterstaat, the Directory of the Ministry of Waterworks, environmental groups, the network and utility companies, the municipalities, the provinces, the water boards, they all are very great stakeholders. And I didn't translate these sheets because I was a little bit short in time, but to give you an impression that these numbers are not just numbers I figured out. This is the amount of kilometers of railway, motorways we have in the Netherlands, our mobility network. These are the number of dikes and rivers we have to maintain. And also, this is the number of main waterways we have in the Netherlands. If you look at the square kilometers of water we have to keep track of and all the dikes around it, it's enormous. And that's where we spend our infrastructure on. This is the railway system which we have to replace at the moment. And we do a lot of tunneling because equal passing is quite dangerous. We have a lot of accidents there. But also we have to bring in the high-speed railway at the moment. It's important for our economy. And then the risk-based asset management. A colleague of mine will also present it, but I took this picture just to show you that for smart cities, a lot of people talked about it, we need a replacement strategy for all our aging utilities. We have a lot of leakage in our utilities and gas blowouts, and they are related to the subsurface. And one of the main things is the climate conference in Paris is climate change. The municipality, like municipality of Amsterdam, have major flooding due to undercapacity of the sewage system. So we have to replace in a larger sewage system. And we cannot do that in once. And this is the things which happen quite 3 or 4 times a year in the Netherlands now. This is The Hague, thanks to a colleague of The Hague. These are the sewage system in The Hague, and you see that the 1880 and 1910, 1911, 1930, and up to 1950 probably have to be replaced because they're under capacity. It's a huge investment, even bigger than the annual investment we make in the Netherlands in our infrastructure field. And this is public-private partnerships often. And they have risk-based asset management, PAS 55, if you're familiar in that, and they use that. Now this is all complex, and now we're going to take you to another route. This is all the adult route, where we're going to go into routes where it's more applicable for politicians and for the general public and for children, the next generation. This earth, we only have one. We have to live on it, and for a long time. So, to keep it simple, there is no surface without the subsurface. Yeah? So a lot of people, a lot of engineers tend to forget. In the integrated spatial planning, often planners and spatial planners only see the subsurface. They forget the subsurface. In Rotterdam, we do integrated spatial planning. We're implementing a program where we also want to really check that people start using integrated spatial planning and use this data in the planning phase. And if you look at the subsurface data, as archaeology, tree roots, funding up to 25 meters. If you go a little bit deeper, it's called a more of heat exchange systems, water storage, a lot of other things there. And then you have geothermal energy, CO2, and all the other energy sources. So what is the user requirement for this key registry? Reduce construction failure costs in the public sector. It's enormous. Cost benefits are enormous. Integrate spatial planning, 3D coupled modeling, combine surface topography with subsurface models. Risk-based asset management, estimate reduction on lifetime capacity of networks, make a strategy for replacement. And coupling between building and information models, BIM, and geological models, GeoBIM, different definition than yours. And we work with a lot of the landscape of the standards in the service. But in the Netherlands, already this is a picture from Amsterdam, tree roots and the cable. We saw a lot of these pictures today. But where is the geology? Where is the real Earth? I didn't see them. Where is it? In our national spatial dimensions information models, we are working very hard on the service models, the BIM, IBOR, IMGEO in 3D topography, but we want to couple them to the subsurface. And that's where we now, we're in the domain of that. That's a very important coupling. So we use the BIM, and this is also my colleague from the Rijkswaterstaat will talk about it. We use that also, probably supporting it by the law, by all our subcontracting. We enforce that. We use in the value chain, and this is from my British colleagues, and he will come tomorrow. I have some colleagues from the BGS and Chandler. They talk about how they implemented this in the UK. They already are doing it. 1 January 2016, it's obligatory in the UK to use the geology in your G design. And here you see from London, where they start doing that in a major construction environment. And they deliver data in different formats. One of the formats was Minecraft. And then I know my good friend, Professor Henk Scholten. And I thought, hey, this is cool. Because Minecraft, that reminds me of my youth. And we can also deliver the geology in building blocks like this. So how do we raise also, even for the minister, of a lot of civil servants in the ministry of civil engineers, or the majors from a city are going to Maastricht, and he doesn't know about the subsurface and the importance of it. How do I raise it? By education and raising public awareness. What's the problem with the subsurface? You do not see it. It's complex. The effect of human activities only are 10 or 20 years later. It's a domain for professionals, geologists, etc. 3D, 4D visualization software for the subsurface is very expensive. Schlumberger, Halliburton, IRAP, to 500,000 euros. Only oil and gas can pay for that. And in the public sector, there's no subsurface department. There's all these domains. There's nobody responsible for the subsurface. It's very interesting. In Rotterdam, they made an ambassador for the subsurface. Any project, he will sit there and know which data is available, so people take account of what is important for the subsurface. Spatial planners only look at the horizon. Civil engineers underestimate the complexity. Politicians are not aware until disaster strikes. There's a need for easy and fun to use the visualization for the subsurface at low cost. That brings home the message. What we do not see is not there. We had some politicians who did this, and I know they had really some sweat on their head, especially in Groningen. Spatial planners. They only look at the horizon. We have some very brilliant Dutch spatial planners. We won this award for making New York water resistant. But look, where's the subsurface? This all. Civil engineers, I think they underestimate complexity. With thanks to Rotterdam, colleagues from the Rotterdam city, just to show you the complexity of the subsurface. Only the cable and pipelines. Yeah? Politicians are not aware of disasters. You see a lot of these gas fields there in the north of Groningen. They produce what we call subsidence, and that's good when the sea level rises and our dikes are lowering with meters because of our gas production, which is, by the way, 50% of our state budget income. We could get flooding, it's very expensive. And we have earthquakes, production-induced earthquakes. Things like this is a P wave. Here, this little image shows it. And now the people who live there know it. What's the value of their houses? And they are not happy, as you can see on this picture. And this minister is not happy either. He has a big challenge. And this is not just going away in 10 years, but the things in the subsurface, system Earth, always takes 1 million years to change. It has a long time. So we have to cope with it and deal with this. In all our piping and cable infrastructure, our dikes, everything we do, our motorways, they will be affected by these P waves, by this seismicity. So, Geocraft is the window to the subsurface. This is a volcano. We have a Dutch volcano where we have even a gas field on. This is an example. We have a gas field platform. And we modeled that in Geocraft. I think it's now to my colleague from Geodam. He is a top 3D modeler, also a geologist. But he imported some of our models in Geocraft just for educational purposes and a low entry awareness tool.
This is a short movie showing the deep geological model below the, this is the Waddenzee in the north of Holland. And I'm just now showing the model I constructed of that volcano that Martin was talking about. And you're now looking from the bottom up through the volcano cone, basically. And so second here is a big graben structure, which is in Limburg, the province of Limburg. And the big fault line you see on the right caused some earthquakes in Limburg as well. And here we see a not to scale model of a production platform with the wells going down into a gas field, and this is near Ameland. So that was just a short movie, and I also will show a live demo here. Let's see. So what I'm showing now is a portion of Geocraft, the public Geocraft server, which a lot of kids in Holland have been playing around with. And they've been constructing Dam Square here in Amsterdam. And we're now looking at the palace at Dam Square. And so they've been hard at work reconstructing the surface and all the buildings, etc. And then I took this portion from Geocraft and included the subsurface as well. So it's a bit.
Where's the entrance?
Well, the entrance is not here, but I created one. I just cut out a block. So what you see here is a shallow geological model of the subsurface beneath Amsterdam, created by TNO. And I included some piles which are under the buildings, as you can see, and some schematic pipes and sewers, and also the Noord-Zuidlijn metro tunnels. So I'll just go through the tunnel. Oops, yeah, it's kind of hard to do this with a touchpad. All right, so we're back at the other end, and this is also a nice view of the metro tunnels and the. Yep. So that's the short demo of the subsurface beneath Dam Square in a sort of easy-to-use visualization tool that kids can understand.
So this Geocraft and Subsurface, educational purposes, raising awareness of general public, combines subsurface topography with the surface, raising awareness importance of the subsurface, low cost and easy accessible tools for non-professionals, because all the other tools are for the professional use. And they are in the municipalities and out at the Rijkswaterstaat and a lot of places. But this is really for the non-professionals. It could be developed into a serious business game for spatial planning and geodesign, community-based participative planning, and risk-based asset management, just as a first check in the planning phase. That's my message.